Download this code from codegive.com, link in the description below. Code review of while loops, a comprehensive guide. While loops are a fundamental control flow structure in programming. They allow you to repeatedly execute a block of code as long as a specified condition remains true. While conceptually simple, while loops can easily introduce bugs, performance issues, or readability problems if not carefully written and reviewed. This tutorial provides a comprehensive guide to effectively reviewing code that uses while loops, covering common pitfalls, best practices, and providing actionable feedback. Understanding while loops. Before diving into the review process, let's briefly recap how while loops work. Key components asterisk condition a Boolean expression that determines whether the loop continues. The loop executes as long as the condition evaluates to true. Loop body the block of code that's executed repeatedly. Update of condition the loop body must modify the variables involved in the condition. Failure to do so can easily lead to an infinite loop. 2. Common pitfalls of while loops. Understanding potential problems is the first step to effective code review. Here are some of the most common issues to watch out for. 1. Infinite loops the most common and often frustrating problem. An infinite loop occurs when the condition never becomes false. 2. Off by one errors these errors arise when the loop executes one too many or one too few times, often due to incorrect comparison operators, example using instead of equals. 3. Incorrect condition the loop might not execute when it should, or it might execute unnecessarily due to an incorrect logical expression in the condition. 4. Performance bottlenecks loops can become performance bottlenecks if the operations within the loop are inefficient, especially when dealing with large data sets. 5. Side effects modifying variables outside the scope of the loop can lead to unexpected behavior and make the code difficult to reason about. 6. Readability and maintainability complex loop conditions, nested loops, and convoluted logic within the loop body can make the code difficult to understand and maintain. 7. Unhandled exceptions if an exception occurs within the loop body and is not handled, the loop will terminate prematurely, potentially leaving the program in an inconsistent state. 8. Modifying the iterated collection if the loop iterates over a collection, list, set, dictionary, and modifies the collection within the loop can fail or produce unexpected results. 3. Code review checklist for while loops. This checklist provides a structured approach to reviewing while loops effectively. 1. Infinite loop prevention condition evaluation carefully examine the condition to ensure it will eventually become false. Ask yourself, under what circumstances will this condition become false? Is it guaranteed to happen? Update within the loop verify that the loop body modifies at least one variable used in the condition. If not, it's almost certainly an infinite loop. Example Review feedback this loop appears to be missing the increment step for I. Without incrementing I, the condition I10 will always be true, leading to an infinite loop. Please add the line I equals I plus 1, or I plus equals 1, to the loop body. 2. Condition correctness and off by one errors logical accuracy ensure the condition accurately reflects the desired loop behavior. Is it intended to include the boundary value or exclude it? Use test cases to verify. Comparison operators double check the comparison operators, equals. Are they appropriate for the intended logic? Initial value verify that the initial value of the variables used in the condition is appropriate. Asterisk example asterisk. Review feedback asterisk. It's important to double check the loop condition to ensure that my_list I does not result in an index error. Given that list indices start at 0 and go up to len, my_list, 1, the condition I len, my_list, is correct for iterating through every element of the list. However, ensure that my_list is initialized correctly before entering the loop. 3 Performance considerations asterisk. Asterisk algorithm efficiency asterisk. Is the algorithm used within the loop efficient? Could it be optimized, example using a different data structure or algorithm? Consider the big O notation of operations inside the loop. Asterisk unnecessary computations asterisk. Avoid performing redundant calculations or creating unnecessary objects within the loop. Move constant expressions outside the loop. Asterisk example asterisk. Review feedback asterisk. Calculating len, my_string, in each iteration of the loop is inefficient. The string length doesn't change. Calculate it once before the loop and store it in a variable. For readability and maintainability asterisk. Asterisk clarity of condition asterisk. Is the loop condition easy to understand? Use meaningful variable names and avoid overly complex boolean expressions. Consider extracting complex conditions into separate functions with descriptive names. Asterisk conciseness asterisk. Is the loop body concise and well structured? Break down long blocks of code into smaller, more manageable functions. Asterisk comments asterisk. Add comments to explain the purpose of the loop, the condition, and any complex logic within the loop body. Asterisk alternative constructs asterisk. Consider whether a for loop would be a better fit. For loops are generally more readable when iterating over a known sequence or collection. Avoid while loops when a for loop is more appropriate. Asterisk example asterisk. Review feedback asterisk. The while loop condition is difficult to understand at a glance. I recommend extracting the condition into a separate function with a descriptive name. This will improve readability and maintainability. For example, 5 side effects and scope asterisk. Asterisk variable scope asterisk. Be mindful of the scope of variables used and modified within the loop. Avoid unintentional modifications to variables outside the loop's intended scope. Asterisk side effects asterisk. Minimize side effects within the loop body. If possible, keep the loop focused on a single task. Asterisk example asterisk. Review feedback asterisk. Modifying the global variable global_counter inside the process_data function creates a side effect. This can make the function harder to understand and test. Consider returning the updated value of the counter instead of directly modifying a global variable. 6 Exception handling asterisk. Asterisk. Anticipate potential errors asterisk. Identify potential exceptions that might occur within the loop body, example index error, type error, value error. Asterisk. Handle exceptions gracefully asterisk. Use try, except blocks to handle exceptions and prevent the loop from terminating prematurely. Log the error if appropriate. Asterisk example asterisk. Review feedback asterisk. The code is susceptible to a zero division error if any element in data is 0. It's crucial to add exception handling to prevent the program from crashing. Use a try, except block to handle this potential error. 7 Modifying iterated collections. Asterisk. Avoid modifying the list while iterating. If the loop modifies the same list which is being iterated over, then unexpected behavior is very likely. Asterisk. Create a copy for iteration. To avoid modifying the original list during iteration, you can create a copy of the list to iterate over. 4. Example code review scenario. Let's consider a complete example and walk through the review process. Review comments asterisk. 1 Purpose clear asterisk the doc string clearly explains the purpose of the function. Good. 2 Infinite loop check asterisk the loop increments I in each iteration, ensuring that it will eventually terminate. The condition I len, data, appears safe. 3 Boundary conditions asterisk if data is empty, the loop will not execute, and the function will correctly return -1. 4 Readability asterisk the code is relatively easy to understand. 5 Alternative asterisk a for loop with enumerate might be slightly more readable. Review feedback asterisk the code is functional and correct. However, for improved readability, consider using a for loop with enumerate. This removes the need to manually manage the index I. 6 Early exit asterisk function returns immediately when target is found. Good. 7 Edge cases asterisk what happens if data is none? The code will raise a type error. Suggest adding a check for that case. Review feedback asterisk consider adding a check at the beginning of the function to handle the case where data is none. Raise a type error or return none. 8 Type hinting asterisk add type hinting to improve code clarity. Review feedback asterisk add type hinting for the parameters data and target and the return type of the function. General tips for effective code review of while loops. Asterisk be thorough asterisk don't rush through the review process. Take your time to carefully examine each loop. Asterisk ask questions asterisk if you're unsure about something, don't hesitate to ask the author for clarification. Asterisk provide specific feedback asterisk instead of saying this loop is bad, explain why it's bad and suggest concrete improvements. Asterisk focus on prevention asterisk the goal of code review is to prevent bugs and improve the overall quality of the code. Asterisk test cases asterisk if possible, write test cases to verify the behavior of the loop under different conditions. This helps ensure that the loop works correctly and handles edge cases. Asterisk context matters asterisk the review should always be conducted in the context of the project requirements and coding style. Asterisk automated tools asterisk use linters and static analysis tools to automatically detect potential issues, example unused variables, code complexity. These tools can often catch simple errors that are easy to overlook during manual review. Examples: Pylint for Python, slint for JavaScript. Asterisk reviewer expertise asterisk the reviewer should have a good understanding of the programming language and the specific problem domain. By following this guide, you can significantly improve the quality of your code and prevent many common problems associated with while loops. Effective code review is a crucial part of the software development process. Remember that the goal of code review is not just to find bugs, but also to improve the overall quality, readability, and maintainability of the code. Good luck! Okay, let's dive deep into code review for while loops, covering best practices, common pitfalls, and providing a practical example. What is code review? Code review is the systematic examination of computer source code. It's a crucial part of software development that helps improve code quality, reduce bugs, share knowledge among team members, and enforce coding standards. It's not just about finding errors, it's also about making the code more readable, maintainable, and efficient. Why code review while loops? While loops are a fundamental control structure in almost every programming language. However, they're also a common source of bugs, particularly infinite loops a loop that never terminates because the loop condition never becomes false. This can lead to program hangs or crashes. Off by one errors the loop executes one too few or one too many times, resulting in incorrect calculations or data processing. Inefficient execution the loop's condition check or body contains unnecessary or poorly optimized code. Asterisk readability and maintainability. Asterisk the loop is written in a way that makes it difficult to understand or modify. By reviewing while loops carefully, we can prevent these problems. General code review principles, applicable to while loops. Before we focus specifically on while loops, let's cover some overarching principles of code review. 1. Understand the purpose. Asterisk before diving into the code, understand what the loop is supposed to accomplish. What is the broader context of the code where this loop is located? This will help you assess whether the loop is designed correctly and is achieving its intended goal. 2. Clarity and readability. Asterisk code should be easy to understand. Asterisk use meaningful variable names. Avoid single-letter variable names, except perhaps for simple loop counters like I. Asterisk add comments to explain complex logic or the purpose of the loop. Asterisk use consistent indentation and formatting. Asterisk break down long lines of code for readability. 3. Correctness. Asterisk the code should work as intended and produce the correct results. Asterisk test cases are essential. Make sure the code has adequate unit tests that cover various scenarios, including edge cases. Asterisk manually trace the execution of the loop with different input values. Asterisk consider boundary conditions and edge cases. 4. Performance. Asterisk the code should execute efficiently. Asterisk avoid unnecessary calculations within the loop. Asterisk choose appropriate data structures and algorithms. Asterisk profile the code to identify performance bottlenecks if needed. 5. Maintainability. Asterisk the code should be easy to modify and extend in the future. Asterisk follow coding standards and best practices. Asterisk write modular code that is easy to reuse. Asterisk avoid code duplication. 6. Security. Asterisk the code should be secure and not vulnerable to attacks. Asterisk validate user input to prevent injection attacks. Asterisk use secure coding practices. 7. Error handling. Asterisk the code should handle errors gracefully. Asterisk check for potential errors before they occur. Asterisk handle exceptions appropriately. Asterisk log errors for debugging purposes. Specific considerations for while loop code review. Now, let's focus on the specific aspects to look for when reviewing while loops. 1. Initialization. Asterisk are all necessary variables initialized before the loop starts. Variables used in the loop's condition or body must have valid initial values. Failing to initialize a variable can lead to unpredictable behavior. 2. Loop condition. Asterisk is the loop condition correct? Does it accurately reflect the criteria for continuing or terminating the loop? Asterisk will the loop condition eventually become false? This is critical to prevent infinite loops. Carefully consider the logic that influences the loop condition. Asterisk is the loop condition too complex? A complex condition can be difficult to understand and maintain. Consider breaking it down into simpler parts or using helper functions. Asterisk are there any potential integer overflow issues in the loop condition? If the loop condition involves arithmetic operations, make sure that the results will not exceed the maximum value of the data type. Asterisk is the loop condition using the correct logical operators, and, or, not. Double check that the logical operators are used correctly to achieve the desired behavior. 3. Loop body. Asterisk does the loop body perform the intended actions? Verify that the code inside the loop is doing what it's supposed to do. Asterisk are there any side effects within the loop body that could affect the loop condition? Side effects can make the loop logic harder to reason about. Asterisk is the loop body efficient? Avoid unnecessary calculations or operations within the loop. Move any calculations that don't depend on the loop variable outside the loop. Asterisk is the loop body modifying the loop variable correctly? the loop variable must be updated in a way that will eventually cause the loop condition to become false. Asterisk, are there any potential exceptions that could be thrown within the loop body? Handle exceptions appropriately to prevent the loop from terminating prematurely. Asterisk, can the code inside the loop body be factored out into separate functions? This makes the code more modular and easier to test. For loop termination asterisk. Asterisk, are there any alternative ways for the loop to terminate? Example, break statement. Make sure that the loop's termination logic is clear and well defined. Avoid using break excessively, as it can make the code harder to follow. Asterisk, is the loop terminating under the correct conditions? Test the loop with various inputs to ensure that it terminates as expected. Asterisk, is there any code that needs to be executed after the loop terminates? Make sure that this code is executed correctly. 5 edge cases and boundary conditions asterisk. Asterisk, what happens if the input is empty, example an empty list? Asterisk, what happens if the input is very large? Asterisk, what happens if the loop needs to execute 0 times? Asterisk, what happens if the loop needs to execute a very large number of times? Asterisk, are there any special cases that need to be handled differently? 6 alternatives to while loops asterisk. Asterisk, could a for loop be used instead? For loops are often more readable and concise when iterating over a known sequence of values. Asterisk, could recursion be used instead? Recursion can be a more elegant solution for certain problems, but it can also be less efficient than while loops. Asterisk, could a library function or built-in method be used instead? Many programming languages provide library functions that can perform common tasks more efficiently than writing a custom loop. For example, Python's map, filter, and list comprehensions. 7. Consider using enumerate asterisk when you need both the index and the value of an iterable. Use the enumerate function for more readable code. 8. Loop invariance. While not always directly applicable to every simple while loop, consider if the loop has an invariant. A loop invariant is a condition that is true before the loop starts, remains true after each iteration of the loop, and is true when the loop terminates. Identifying loop invariants can help you reason about the correctness of the loop. Code example and review walkthrough. Let's consider a complete example and go through a code review process. Code review walkthrough. 1. Understanding the purpose asterisk. The code aims to remove duplicate elements from a list, maintaining the original order. This is a reasonable and common task. 2. Clarity and readability asterisk. Asterisk, the function has a clear docstring explaining its purpose, arguments, and return value. Good. Asterisk, variable names, data, scene, result, are meaningful. Good. Asterisk, the code is well formatted and easy to read. Good. 3. Correctness asterisk. Asterisk, initialization asterisk. I is initialized to 0, scene is initialized to an empty set, and result is initialized to an empty list. All necessary variables are initialized. Good. Asterisk, loop condition asterisk. ILEN, data, is the loop condition. It ensures that the loop iterates over all elements in the data list. Good. Asterisk, loop body asterisk. Asterisk, data I not in scene checks if the current element has already been seen. Good. Asterisk, result dot append, data I, adds the element to the result list if it's not a duplicate. Good. Asterisk, scene dot add, data I, adds the element to the scene set to track that it has been seen. Good. Asterisk, I plus equals 1 increments the loop counter. Good. Asterisk, loop termination asterisk. The loop terminates when I is no longer less than len, data. The result list is returned. Good. Asterisk, edge cases asterisk. Asterisk, empty list asterisk. If data is an empty list, len, data, is 0, and the loop will not execute, returning an empty list. This is the correct behavior. Asterisk list with no duplicates. Asterisk if data contains no duplicates, each element will be added to result, and the function will return a copy of the original list. This is the correct behavior. Asterisk list with all duplicates. Asterisk if data contains all duplicate elements, example 1, 1, 1, 1, only the first element will be added to result. This is the correct behavior. For performance. Asterisk using a set, scene, for checking duplicates is efficient because set lookups, checking if an element is in the set, are O1, on average. If a list were used instead, lookups would be O(n), making the algorithm significantly slower for large lists. Good. Asterisk the time complexity of the algorithm is O(n), where n is the length of the input list. This is generally good for this type of task. 5. Maintainability. Asterisk the code is well structured and easy to understand. Good. Asterisk the function is relatively short and focused, making it easy to modify or extend. Good. 6. Alternatives. Asterisk a for loop could be used instead of a while loop. This could arguably make the code slightly more readable. Asterisk Python's order dict could also be used to remove duplicates while preserving order, though this might be slightly less readable for those unfamiliar with order dict. Conclusion of the review. The original code is well written, correct, efficient, and maintainable. The use of a while loop is appropriate, and the code effectively removes duplicates while preserving order. While a for loop or order dict could be used as alternatives, the original code is perfectly acceptable. No major changes are required. Key takeaways from this example. Think about the loop condition carefully. Is it correct, and will it eventually become false? Consider data structures. Using the right data structure, like a set in this example, can significantly improve performance. Write clear and concise code. Readability is essential for maintainability. Test thoroughly. Test your code with different inputs, including edge cases, to ensure it works correctly. Consider alternatives. Are there other ways to accomplish the same task more efficiently or more readably? By following these principles and paying close attention to the details of while loops, you can significantly improve the quality of your code and reduce the risk of bugs. Remember that code review is a collaborative process, so be open to feedback and learn from others. Good luck.